Welcome to the Pump Performance Lab. I'm Megan Rice, and my favorite holiday is Cinco de Mayo.
Hello, I'm Fatima Abdulatif. I love the Christmas time since it's the time I get to go.
And I'm Mustafa Morsi, and my favorite holiday is Thanksgiving.
And I'm Darren Huggins, and my favorite holiday is my birthday.
Hi, we are here to discuss the objective of this experiment. You will be doing three things. First, quantifying the performance of two different pumps with varying flow rates throughout two different pipes. Here we have three different diameter pipes. You will get to choose two to work with. Second thing is, you will have to determine the friction factor and the orifice constants using the friction meter and the orifice meter. And you will get to compare the flow data from the manual to the flow that you get by adjusting the control valve manually each time. Third and last is you will have to determine the velocity profile through a PVC pipe using the statics meter. Hi, I'm Fatima, and I'm here to talk with you about safety precautions for this lab. First, you must have Google on and sign your name once you get into the lab. You must have long pants and closed shoes as the major personal protection equipment. The first part of the lab, you will be measuring the viscosity and density of the ethylene glycol. So make sure you have gloves on, since the ethylene glycol is irritant, so you need to avoid skin contact. When measuring viscosity and density, you'll have some sample beakers. So in case you brought a little bit less, clear the area and dispose it in the broken glass container. When it comes to here, you'll need to open and close valves every time. So try to avoid pinching yourself when closing and opening the valves. In case any spillage, mop it up and tell everybody that there is a spillage to avoid slipping hazards. When the pumps are on, they have moving parts, so you will need to avoid direct contact with the pumps, so you won't hurt yourself. Make sure to pull out hair and clothes and stay away from the pump as much as you can.
Alright, during the first part of this lab, we're going to have to calibrate the flow meter. And I'm going to show you kind of how this works. First of all, you're going to be using like pump 1 or pump 2, just depending on what you want to do. And you're going to run it through whichever pipe you just choose. Make sure you say that and then it's not an experiment. And it's going to come through, it's going to go through that, and it's going to end up going into this. We're going to route it from back here. I don't know if you can see, there's two different valves back here, and we're going to want to make sure that whenever we do this, we know where they are so we can switch them. So we're going to turn on the pump, and it's going to be running straight into this barrel right here. And whenever we're ready, you're going to flip these two, and it's going to start going up there. And so that's been this weight right here, this barrel right here will start filling up with the water. And so to measure this, we're going to use, it's a scale. We're going to use this. So this is relatively difficult to use. A few groups don't know how to do it. So right now there's zero weight, because this thing's at 0 and this is at 0. So, because this is heavier than 0, this outweighs it. So as we move this down, say we move it all the way, this thing all the way to 20, now it's less than 20 pounds. So you could do this just like any other scale where you found out how much. How we like to do it, how we like to measure it, is we put, for every one of these you add on is 20 pounds. So this is 20, then if we put on like this, 40. So we start below 20 pounds, or it's heavier than 20 pounds. So what we like to do is we like to turn it on. And so we would turn it on, and whenever we would first tilt down, like that, as you can see up here, you can see it go from under to over. When it first goes through 0 up there, we start the clock. And then while it's going, we move this down to the 20, this right here. So now it's 20 pounds heavier. So obviously now it'll go back to the other side. And then whenever it goes straight through it again, that's when we would stop it again. And so the difference in time would be however long it took to get 20 pounds. You're going to do this a few times. You might do, the first one you might do 10 pounds. You might start it at 0 and then move it to 10 and see how long it takes to get 10 pounds. The second you might do 20. Just make sure you talk about that in the design of the experiment.
Hi, I'm Megan Rice and I'm going to explain to you the equipment that we'll be using during this lab. We'll be analyzing 2 different pumps throughout the lab and they're located here. Make sure you know where the valves are that control each pump. Whenever a valve is open, the handle goes in line with the pump, and whenever it's closed, it goes perpendicular to the pipe. There are 4 different tubes on the apparatus. The top tube we don't use for anything during this lab, so you'll only be looking at these 3 different tubes, depending on your design of the experiment. Whenever you continue down the apparatus, we have 4 different meters. There's the meter that collects the data for the pitot tube, the friction drop meter, the pipe orifice meter, and the control valve orifice meter. Whenever you're using the pitot tube, you'll control the radial distance by turning this knob. Down here at the end, these are the valves that control flow through the pipes. So make sure the correct ones are open throughout the experiment. Make sure you don't have 2 open or 1.5. Make sure it's just your 1 pipe that's completely open, unless you're adjusting the flow manually and turning the valve off. Over here we have the watt meter that you'll be using during the pump performance analysis. All you have to do, depending on which pump is on, is press the button right here, and the spindle will change, and then you record that value.
Go.
Hey guys, we're going to demonstrate now how to bleed air out of the tubes. This is important if you want your equipment to work right, especially if you're getting funky numbers. There may be air in the tubes. So how to do that, we will demonstrate now. For example, the friction drop across the PVC pipe. Say you want to bleed the tapping tubes here, you'll need to open the valves along the tube. So the valve here, you need to open the valve across the pressure meter, as well as the valves on the sides. That will bleed the air out of this tube and into that bucket. If you want to bleed the tube on the other side, follow it up here and open the valve until fluid is flowing into the bucket. Once you have fluid flowing into the bucket, you don't need to keep it open. Close it and close the valves on the other side. And that is how you bleed the air out of the tubes. Make sure you wear gloves because this stuff will irritate your skin.
So there are plenty of opportunities for design of experiment throughout this lab. For one, there are 3 different pipes, and at any one time you'll only be analyzing between 2. So you really get to decide whether or not you want to use the bigger diameter tubes or the different materials. Just make sure that you explicitly state that. Also, for whenever you're measuring the friction factor and the orifice constants, you can decide which pump you would like to use throughout that analysis also. And the same for whenever you're doing the velocity profile of a tube. Also, whenever you are analyzing the flow rates through the tube and you're comparing the Honeywell collected data to the manually collected data, you get to determine how much you want the valve open and how many measurements you want to take during that time.
Hi, here I'll show you how to set up the handle system to collect data. For the first part, when you choose the pump pipe that you will work with and have all the correct valves open and the others closed, you get to change the set point flow rate for 6 times at least and record data for that for each pump. For part 2, you're finding the orifice inflection factors. You'll need to, once you have all the correct valves closed and open, you're changing the valve opening this time, not the flow rate, and you will be recording the pressure drop length and pipe orifice from Honeywell system, and make sure to have a copy of the data into Excel so you can use them for your calculations later. And for part 3, you'll have 100% valve opening, and you'll be measuring the velocity throughout the pitot-static tubes. You won't need the Honeywell system pretty much for the third part. That's it.
Okay. Hi guys, my name is Mustafa Morsi. I'll be talking to you about the calculations for the pump performance pre-lab. First, you will need to come up with your pump performance numbers. Start with just your old Bernoulli's equation. The pump head is equal to pump head plus the pressure drop head plus the velocity head plus your elevation head. Same thing over here plus your head loss. Your pressures you will get from your Honeywell or from the pressure gauge. Velocities you will calculate from your flow rate, and head loss you will need to estimate. Elevations you can measure. Once you come up with your pump head, you will need to calculate the efficiency of your pump. This can be done by dividing your pump head by the head shaft, or equivalently, your mass flow rate times your pump head divided by the work delivered to the shaft. I need to say for this part, okay. Next, you'll need to work on your friction factor and orifice. Friction factor can be calculated by multiplying your head losses by the ratio of diameter to the length of your tube, times 2 times gravity divided by the velocity squared. This will get you the friction factor across the length of the tube. This will get you your orifice constant. You'll take your flow rate and divide it by your head drop across the orifice raised to the 1/2 power. Make sure to watch your units on here. This should be units of cubic feet per second. This should be units of feet. And K then will be units of feet to the 2/2 power divided by seconds. Last but not least is the pitot tube. For different distances across the diameter of the tube, you will calculate the velocity of the fluid there by taking the square root of 2 times the difference in your stagnation pressure and your dynamic pressure divided by the density. You will then plot those velocities by the radial distance, and you should get a curve like that. Starts at 0, comes up to a maximum. You'll need to find the average velocity and compare that to theoretical values. And that should be it for calcs. Good luck.